In this lesson, we're going to talk about the mod operator, which is a mathematical operation that is used in a surprising number of applications. Have a look at the example on the left. I've drawn 11 dots, and I want to group those dots into groups of 3. So I could make a group in the top left, like so, those are 3 dots. I could make another group here, and I could make a final group at the bottom there. So I've grouped them into 3s. That's a very easy operation to model in Java. So I'm going to get the number of groups, I'm going to say int groups equals, and I'm going to take my number of dots and divide it by 3. And that'll give me the number of groups, which should be 3 in this case. In other words, 11 divided by 3 in Java equals 3. But what if I want to know how many dots were left out of a group? In other words, these 2 there. And this is where the mod operator comes in. In Java, the mod operator is with percentage. So if I say int, and let's say left out equals, if I take my number of dots and I say mod 3, in other words, I want to group them into 3s, but instead of giving me the division, I want to see who's left out. Then my left out variable will now be equal to 2. Let's print that out just to make sure. System.println, let's say left out, and hopefully when I run that, there's my answer there. 2 dots were left out. So let's look at a real world example. If we take a clock and we want to look at 3 o'clock in the afternoon, which is 15 hours past midnight. If we now move along this along the clock from midnight, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we continue 1300, 1400, 1500. You can see we've wrapped back around to 3 o'clock. Another way of thinking about this would be to think of it as 15 dots. And if we then grouped 12 dots together, like so, then there are 3 dots left outside the group. In other words, after 12 hours have passed, we start again and we start counting from the beginning. 1 o'clock, 2 o'clock, 3 o'clock. So now it's 3 o'clock in the afternoon, 3 dots left outside of the circle. And every 12 hours, we create a new group of 12 and we start counting again. In other words, more dots left outside of a group. Let's look at a similar example in code. Let's say the time is 3 o'clock. And I want to know, what will the time be in 30 hours from now? So I'm going to take my time and I'm going to add 30 hours to it. Now I want to know, what will the time of day be? Well, I can take my time, int time of day, and I can take my time and I can say, if I was to group the time and I represent each hour as a dot and I group them into groups of 12, I want to know how many are left out of the group. So again, I've used the mod operator. And let's see what answer that gives me. Print out the time of day, run it, and there we go, it's 9 o'clock. Okay, you could apply the same with a 24-hour clock. So if we change that from, instead of grouping into 12s, if we group it into 24s, now when I run it, I can see it's actually 9 o'clock at night. Let's look at another practical example. So let's say I have 1 dot, and I group my 1 dot into groups of 2. Now, currently there are not 2 dots, so I don't have any groups. and I have one dot left out of a group. Then if I add one dot, now I can group it into a single group of 2 with no dots left out of a group. Let's keep going. If I add one more dot, I now have 3 dots. I can create one group of 2 and one is left out. Add one more dot, and now I have 2 groups with nobody left out of a group. And I can keep going like this, adding one dot, and you might notice a pattern. When I add 1 here, there's 1 left out of a group. Add one more, none left out of a group. 1 left out of a group, none left out of a group. 1 left out of a group, none left out of a group. There's a repeating pattern. You may also notice that when none are left out of a group, there are an even number of dots. Here I've got 10 dots, nobody's left out of a group. If I add 1, I now have an odd number of dots, and 1 is left out of the group. If I keep going, 12 dots, nobody's left out of a group, and it's an even number. 13 dots, 1 is left out of the group. It's an odd number. Let's say I have a random number of dots between 0 and 100. Doesn't matter if you haven't done random in class yet. Let's print out the number of dots I have. Every time I run my program, it'll be a different number of dots because it's random. So here, when I run it, I now have 18 dots. And now from code, I can check if that number is even or odd. So let's check if I take my number of dots and I find the remainder if I was to divide it by 2. And I check if there is nobody, 0 dots left out of a group. Then that must be an even number. So I'm going to print out even. And if that wasn't the case, so if nobody was left out of a group of 2, then that must be an odd number. There must be at least one person, well, there must be one person left out of the group. All right, let's try that again. I'm going to run it. I'm going to get a random number, 80. And we can see that 80 is even. So I run it again. Here we've got 73, and 73 is an odd number, because if I group 73 into groups of 2s, there would be one person left out of a group. In other words, it's odd. So finally, to test yourself, to see if you've understood this section, ask the user to input a year, and I want you to print out if that year was a leap year or not. Good luck.